So first, I want to talk about this picture right here. So remember we talked about yesterday how when we say two lines, we really mean what? There's a hidden meaning between there. Yes, sir?
Different lines.
That's right, two different lines. So the between actually has, I mean, it's sort of, okay, so between, it actually means something particular. So when I say point B is between A and C, okay, it actually means this. B must lie on the line AB. Okay. Let's see if it makes this. Let's see if this makes sense. So it doesn't make any sense. Okay, but what about here? Is D between AC? You see the point D there? Isn't that between 2 points there? But when I say between in this class, right, in geometry, it means something particular. It means if I say a point is between 2 points, right? A point is between 2 points. Like for example, point B is between AC. That means B has to be right on the line AC. It cannot be like above or below. That's what I'm trying to say. Does that make sense? Because you know what I mean? Because in real life, really, we could say something is between, like, you know, what's between LA to San Francisco? There are a bunch of cities, right? But you know, when we say in geometry, when we say a point between 2 points, it has to be on that line. Do you see what I'm trying to say? So can I say then D is between AC? No, that would be wrong. You see what I'm trying to say?
Yeah.
So like I said, we remember that sort of theme of we all have to be on the same page. That between has special meaning in geometry, right? It has to be on that line. Okay, very good. Let's move on to then segment AC. Okay, let me move it up for you. Here is a picture of segment AC right here, and note this is how we write segment AC, right? With AC with the segment bar on top. Just like, you know how we had line, we had little symbol of line on top of the two letters. For segments, we have the segment bar up here. And I'm going to tell you what a segment AC is. It consists of points AC, and all the points are between AC. So when we say segment AC, we're talking about every point between AC. Now, that between again is it means particular, right? It means that those points must be on the line AC. Does that make sense? Right? We're not talking about any points that are above or below line AC, right? So when we talk about segment, it consists of all the points that are between the 2 point AC. Okay? So it is important that you understand what we mean by between. Okay. Good. I'll wait for you to write this down. I think a lot of you know already that AC are called the endpoints of the segment AC. By the way, when you see this notation, AC with that little bar on top, this is how we read it. We read it as segment AC. Right? Yes, sir?
Is that a period after the A or before?
Comma. Sorry, comma. I'll fix that. Talk about ray. So here's a picture of ray, AC, and it consists of segment AC. And can I stop there? Does that describe this ray? No, it doesn't. And this is how we describe this. All other points P such that C is between AP. Okay. So another way of describing is, can somebody tell us what this is really saying? Because right now it seems like it's saying like there's just a 1 point right outside of C. Is that what they're saying? Okay. Oh, you're writing down. Let me just wait. Well, as you write this down, what's another way of saying this, guys? Yeah.
Ray ACP.
Ray A. No. When you name rays, we only use 2 letters.
Ray CP.
If you write ray CP, no, it would not be same as A. You could write ray AP, yes. But what is it saying? How are they defining this ray? Yes, sir.
Oh, Ray CA.
ray C. No, okay. So I'm sorry. So what I'm trying to say here is, the ray AC consists of the segment AC plus all the points, right? Right side of C, right? Another way, right? But this is when they say array AC consists of segment AC and all other points P such that C is between A and P, right? P could be anything on the right side of P. You know what I mean? That's what we're trying to say. But, you know, do ray always have to point to the right side? No. Does it always point to the left then? No, it could point to any direction. That's why they don't use the right or left. You know what I mean? That's why they chose these words. Do you understand what they're trying to do? Because they don't want the readers to be confused. Because not all, right? Not every ray has to point to the right every time. Right? It doesn't have any, you know, it could be pointing anywhere. That's why they chose these sort of words. Yes? So P could be anywhere to the right in this picture. P could be anywhere to the right side of C. You know what I mean? Yeah, it just continues on. So so how many P's are there? How many points are there? There are infinitely many. So P could be infinitely many points. Okay, it's not talking about just one point. Right? It says all other points P such that. Okay, does that make sense? Because it looks like there's only one point outside, right? It sounds like it's made up of a segment and a point. No, that's not what they're saying. It's all other points, right? That makes this true, where C is between A and P, right? So P could be anywhere the other opposite side of AC, I guess. Okay, may I move on? So again, they're doing, okay, by the way, the endpoint of AC is A. And whenever we name this, let me see if there you go. I said this. I'm going to actually highlight this. The endpoint of AC is A, and whenever we name rays, I think I mentioned this before, you need to name the endpoint first, okay? Endpoint first. So in other words, you cannot write this as, you cannot do this. Let's see if I could do that one. Can you do this? Can I write C, A, and then this way? Can I do this?
What's that word after
No,
point?
this is wrong. Okay. You cannot, right? That's not the right way of writing a ray. What did you say, sir? Oh, you got it. Yeah, you don't feel free to ask your neighbors if something isn't clear, or that's fine with me. Okay. All right. Let's move on. Guys, what do you think this is? What does this look like? It's a line, of course, right? You could say line RS, line ST, line RT, or any orders you want. Line doesn't matter. But another way of describing this is we could use this as an opposite ray also. So same thing, okay, as line. But if you happen to have this, I could also describe this as SR and ST are called opposite rays. Okay? So if I'm talking about those two rays together like that, right, where they have the endpoints at S, both of them, right? These are called opposite rays if S is between R and T. And notice that between, that word between also is, right, it means particular, right? S is between R and T means S has to be on the line of RT, okay? And notice how we name these. Is it okay to name RS with the ray going to the left side? No, that'll be wrong, okay? Notice how we name these rays. SR and ST, right? Those are the endpoints of those two rays, okay? The question is, could we call this an opposite ray if they weren't perfectly opposite of each other? Meaning, if it wasn't like some angle? No, then it would be called an angle, not an opposite ray. Does that make sense? Okay, so it has to be 180 degrees. Okay, they're really opposite. All right. So we're going to change the gear a little bit. We're done with sort of definitions and so forth. Let's say that I have this number line. Can somebody tell me the distance between AC? Can somebody tell me the distance between those 2 points A and C? What would that be? I have the... actually, since I have a signature, let me just call on someone here. How about Jack? What do you, sir? What do you think, sir? Where are you, Jack? Oh, wait. I'm in the wrong period. Okay. Jonathan. Jonathan. Yeah. What do you think? What's the distance between AC? 6? Yeah, 6. You just count, right? Here. 1, 2, 3, 4, 5, 6, right? I mean, hopefully these are... sort of wasn't careful, but you know these units to be same units away, right? Each unit should be all same. Yeah, 6, because from here to this 4 you add 2 together. Okay, so that's 6. That's easy. Now, what if then I don't have this picture, but what if I have a line that's really, really long? Are you gonna count like every time? Is there an easier way to get the distance between 2 points on a number line rather than counting? Because what if they're like, I don't know, 3,000 units away or something? You know, I'm not gonna count all that unit. Is there a nice way once you have this number line and so forth? How about Andrea? What would you do?
You subtract the bigger number from the small.
Yeah, you subtract big number from small. Like here, does this work? From A to C, what's a bigger number? 4 or negative 2? 4. So what's 4 minus negative 2, guys? 6. See, that works out. Now, what if, is there a way to do it so that you don't have to always choose a bigger number? In other words, is there a way to get the distance, right, without starting always with the bigger number first? Oh, how about Emily thinks?
Negative smaller number plus.
Oh, okay, you could do it that way, sure. Does that work every time? What if the 2 numbers were positive? Does this still work? There's the actually easier way. Let me give you a hint. Is it? Let me give you a hint. Use the what? Absolute value. If you take the difference, if you take the absolute value of their difference, right, it doesn't matter which one you choose then, right? Because remember, absolute value makes everything positive. So that's what I'm trying to get at. So you could also just take the absolute value. So to find the distance between two points, you just use their coordinate, and then you just take the difference of their coordinate, and then take the absolute value. You always get the distance. And of course, distance is always positive, right? So it makes sense, right? You take their difference, and you get the distance. Okay. Oops. Okay, so here we go. I have a bunch of number lines, so no, you don't have to draw this thing. I just try, and I'm just trying to make a point. When you draw a number line, guys, assuming that each of those units are all same, I wasn't really careful. Does it matter how? Like, there's so many ways of drawing number lines, isn't that right? Right? It really depends on how much unit you want to make. Do you want to make this thing to 1 unit, right? So anyway, kind of keep that in mind as I talk about this first statement. By the way, in geometry, there are statements that are accepted without proof, okay? Because we got to start somewhere, okay? We cannot prove every single. So statements that are accepted without proofs are many times called postulate, or another name for that postulate is called the axiom, okay? So there are statements that we just take it as truth, okay? Because we need some starting point. You know how okay, let's see if we remember. What were 3 terms that we do not define? Points, lines, and plane, right? So we got to start somewhere. So same thing here. There are some statements that we're going to take it as truth. Okay, we're just going to believe it. It's just true. And so these are called postulates. And so one of the first postulates that we're going to learn, or axioms, some books calls it, is called the ruler postulate. Okay. And what this does is, the whole point of this ruler postulate, you don't have to memorize this postulate, by the way. There are a whole bunch of postulates and theorems you have to memorize. This one is not one of them. And you will find that if they give you a name, okay, you don't have to memorize the actual postulate or theorem. Okay? But you need to know what it's talking about, right? But you don't have to memorize it. If they don't give, if there is no name, guess what? You have to memorize. Huh?
Yes, write out the entire definition.
Yep, you have to memorize it, and then when you're using those in the proofs, you have to write it out. But if you understand them, it's easy to memorize and know. Yes, sir.
You have to do word for word.
I'm gonna just say right now, word for now, and yeah, because once you start paraphrasing things, and if you don't say it correctly, that's totally wrong. Okay, so I don't want you to, but I mean, they're not that bad. Okay, it should make sense too. And if you miss some words and it doesn't change the whole meaning, I still take it. Okay, so don't worry. Okay, we'll talk more of that in a minute. Okay, so anyway, the whole point for this ruler postulate, just keep this in mind. We want to determine a coordinate system. Right now, we're not even talking about 3-dimension or 2-dimension. We're just talking about on a number line. We want to determine a coordinate system, right? What do I mean by coordinate system? How is coordinate system on a number line? Anybody have any guess? How do you determine a coordinate system on a number line? In other words, how do we put like 1, 2, 3, 4, 5, 0, and all that stuff on a number line? In other words, when you do your homework, let's say somebody said draw a number line. How do you do that? How do you draw a number line? Yeah. With the ruler, okay, so maybe that's why it's called ruler postulate. But do you just, with the ruler, do you just draw one line? Is that it? No, we have to determine what? We have to define what? I mean, not define. We have to assign numbers on them. Units. Somebody said units, right? Does that make sense? So in all these units on a number line, they have to be in the, using the same unit. So here's what it says here. So we're going to now basically do this. You see how we did all this right up here? Okay. All these number line that I just did? This is what we're trying to do. So if you have, so let's see if it makes sense.
Oh my
Watch
gosh.
you don't have to write this down, sorry. Just write down just write down the name, and this is on your book anyway, so you don't have to write the whole thing down, okay? To save time and so forth. If you want to, you can, but do it at home, okay? I don't want to waste time. Okay, yeah. So first, let's just read it together. So the point, so what we're trying to do, so we're trying to determine a coordinate system. So here, the points on a line can be paired with real numbers. By the way, may I ask you this? Let's just stop right there. Points on a line. How many points are there on a number line? Raise your hand. Raise your hand. You raise your hand, sir. What do you think? How about Lauren? There are infinitely many of them, right? So how many numbers are there? How many real numbers are there, guys? Infinitely many of them. You see how they can be paired? Right? They can be paired in such a way that any 2 points can have coordinates 0 and 1. And this is just basically assigning length of a unit. Here's what I'm trying to say. We're just basically drawing a number line, okay? So then when you draw a number line, don't you draw a number line and then don't you put like, whoops, where did it go? There it is. Okay, when you draw number lines, right? Don't you need to know like how much is 1 unit, right? Right? So if you have 0 and 1, now that determines 1 unit, and then you kind of go on forever, right? You see what that means?
Yeah.
Okay, so we basically, and then once we did this, why do we do all this work? Once we did this, can somebody read the second part? Yes, go ahead.
Once a coordinate system has been chosen in this way, the distance between any 2 points equals to the absolute value of the difference of their coordinates.
And we just did this, right? Once you have this coordinate system this way, right? We know how to find the distance. So basically, we're doing this so that we could actually have this coordinate system, and we could actually find distance between these 2 coordinates. Does that make sense? So don't worry too much about this. We're just basically defining a number line, right? And in a number line, you could make a unit of 1 unit to be anything you want, right? Once you've chosen that, and that unit is the same throughout the whole thing. So don't worry. But what is important is this. By the way, distance between 2 points. So write this down. This one is not on a. This is important. So the way we denote distance, the distance between 2 points AB is denoted by AB, just AB. Note that there is no line segment symbol on top. So if I just write AB this way, we're talking about what, guys?
We're not a line.
Hmm? Distance. We're talking about distance. And distance is a numerical value, right? It tells you either 5 meters, 5 centimeters, you know what I mean? Like 10 feet, right? 1,000 kilometers. Distance is a measurable unit, right? Does that make sense? So this is a number. It equals to some number. Okay. So when we talk about distance, it equals to some number.
Why is there no line segment?
Okay, so when we put line segment, we're talking about an actual segment. We're not talking about the distance of the segment. Do you see the difference? If I write AB with the segment part on top, I'm not necessarily talking about the distance of the segment. I'm just talking about that segment itself. You know what I mean? But if I say AB only like that means I'm talking about the distance between those 2 segments. Do you see the difference? Okay. All right. We'll talk about that a little bit more. So please note that this is how we notate distance. Okay. So This is important. This one is not that hard to write and it's not that long. And this you need to know what it is and write it down. So postulate 2, we take this as true, and I think we could all believe this to be true, hopefully. Okay, it's called segment addition postulate. If B is between AB, again, that between means particular between, right? Not just sort of everyday between. If B is between AC, then AB plus BC equals to AC.
Wait, are we writing that?
Yes, this one you're writing. Okay, this one you're writing. So I'll give you time. And think about what this means. This says a lot. Like, it's very short, but this says a lot about what we just talked about. Even in the way we wrote this. We wrote AB, not with the segment symbol on top, right? Okay. And this, we take it as truth. Do you believe this?
Yeah.
Yeah, because this is sort of obvious, isn't that right? What is it saying? Can somebody tell me? Good. Not all of you. I want you to discuss with this your group. Go ahead. See if your group agrees with you. What do you think this means? Let's move on. I mean, let's talk about this. All right. Who thinks they understand what this is saying? Saying something so obvious and trivial, maybe you're like, oh, what? I knew that already. Why are you even saying this? Okay. How about Nia? What do you think? Oh, I mean, Sarah. What do you think?
Oh, well, it's like there's y and then AB is like one part and then BC is like the other part. So if you add the two of them, they make the whole thing.
And we're talking about particularly what? Are we talking about the actual segment, or what about their segment here? The important thing is you're right. It basically, here's an example, guys. Here's ABC. Do I have a line segment? Do you see a line segment AC? Yeah? Do you see it? Okay. What's AB? 1. Very good. Why did you say 1? Because when I say AB, what am I asking? Really?
Distance.
Yeah, what's the distance of AB, right? What's BC, guys? 4. So, using this postulate or this fact, okay, what are they saying? What's AC equal to? 5. That's what it's saying, okay? So obvious. Everybody knows. Yeah, everyone knows. Any question? That's all it's saying. Okay, it's very trivial. Okay, so basically, and do you see why it's called segment addition postulate? Yeah, when you add two segments, you get the distance of the whole segment. Right? If you add the distance of these two segments, you get the whole segment. Distance of the whole segment. Everybody understand?
Yeah.
Do you see why we didn't put any segment bar on top here? Right? Because what are we talking about again? We're talking about the distance. Let me highlight this. Okay, we're talking about the distance. Okay, any question? So they're basically saying that AB plus BC is AC, right? Which means the distance of AB plus distance of BC, these two segments, equals to the distance of the whole segment AC. Very simple. Okay. Do you think we could have line addition postulate? Yeah, line addition. No, why not? Yeah, line goes on forever. How you get a distance of it? Okay, you get the idea. Any question? Oh, I said this again. You don't have to write this down. Okay, so, all right. Any question? So this is our first postulate that you really have to know. Okay. Oh, this is actually the second one. The first postulate is ruler postulate, right? Ruler postulate is actually this establishing, right, a ruler or a number line, right? Okay, and establishing coordinate, all right. And so if we have that, this second postulate is the most important thing you need to know. Segment addition postulate. Okay. Basically, when you add two segments, you get the whole one, the whole segment. I mean the distance, right? When you add the distance of these smaller pieces, you get the whole thing. If the C is in between A and C, right? And you all know what we mean by between, right, guys? When we say C is between A, C, I mean B is between AC, it means B has to be on that line AC. Okay. Are we good? Perfect. Let's move on then. So in geometry, two objects that have same size and shape are called, oops, I'm supposed to hide this. Okay, fine. Congruent, okay? When you have this, so there are two things that you need to know in order for two objects to be congruent. Can they just have the same size? No, they have to also have same shape, okay? So please keep that in mind. That's a definition, okay, of two objects that are congruent. Okay, so that's you need to write down. Okay, all right. So now here's kind of interesting. I just told you congruent figures must have same size and shape, right? And look what I say about a segment. It says congruent segments are segments that have same equal length. How come I don't say anything about the shape here?
Because that's not considered as a shape.
Well, yeah, so all the segments, right? All the segments, they look, they all look the same. So we don't have to worry about the shape, right? So therefore, look at these two segments. Are these two segments congruent?
Yeah.
Yes. So how would you say this? Segment DE is what, guys? Congruent to segment FG because they have the same measurement, right? We don't have to worry about the shape. They all look the same. But here's what's important. Oh, question. Yes, sir.
You say no considered as a shape.
Yes.
Okay.
Yes. Okay. So that, but actually, yeah, well, we'll get there in a minute. Very good. Okay, you're thinking ahead. Now, how would you then write this correctly using symbols? By the way, does anybody know? Yes, sir. Oh. How would you write the two segments are congruent in mathematically? Like, you don't have to write it as a whole sentence. Instead of writing segment DE is congruent to segment FG, there's a shortcut of writing this. Yeah, what do you think?
It's DE with the line is the squiggly line that looks like.
Yeah. Very good, very good. Have you guys seen the equal sign with the squiggly line on top? Okay. All right. So that's how you write segment. So, whoops, right here. Right here. Okay. So DE, write down. You see the highlighted. I want to hide this thing. It's okay. D is so to write D is congruent to segment FG. You do D, the segment symbol with congruence. This is a congruent symbol, and then FG. Okay. So, by the way, why is this okay too? FE equals to FG. What do we mean by D? I mean DE. When I say DE, this means the distance of DE, and distance is a number, right? So how do you say that a number is equal to another number? You just use equal sign. You see here, we don't use equal sign because these are not numbers, are they? They are figures, right? These are segments. Do you see the difference? Do you see when to put the segment bar, right? When to use the congruence symbol? So here, this is kind of saying 3 centimeters equal to 3 centimeters, basically, because they're talking about numerical length, right? Numerical distance. Okay? So please keep that in mind. Number is always equal to a number, but here, we're talking about the segments. We're not talking about their length or distance, okay? So do you guys see the difference between these two statements here? When I say DE is equal to FG, what am I saying here on the left? I'm saying, how about, I would like to, how about, Lara, what am I saying when I say D is equal to FG on the left?
Talking about the distance.
That's right, I'm talking about their distance, right? I'm talking about the distance of DE, whatever it is, maybe 3 centimeters, right, equals to the distance FG. So we're saying 3 centimeters equal to 3 centimeters. What about on the right? How's that different? How about, who haven't I called today? I haven't called. Yes, how about Jonathan? Yeah. No, I'm sorry, not Jonathan. Johan.
It's talking about the actual line segment.
Yes, it's talking about the actual line segment. And what is it talking about in terms of the line segment with that congruent symbol in there? We're saying these two line segments are what? Ryan? They're congruent, meaning that they have the same shape and same size. Is that okay? Do you guys see the difference? All right. Okay, now we're going to talk about midpoint of a segment. You all know what a midpoint is, don't you? Okay, hold on. Let me move this up for you. Okay, so what do you guys, take a wild guess. What's a midpoint of a segment? What do you think? We're defining this now. Okay, who haven't I called? How about Daniel? Have I called you? No. Daniel, what do you think midpoint of a segment is? Yeah, it's the point in the middle. Basically, let's see how they describe. Okay, so it's just this is how so that people are not confused. Okay, if you just say middle, what do you mean middle? Okay, so this is how they define it. A midpoint of a segment is the point that divides the segment into two congruent segments. Notice how they're using congruence so fast now. Now that we have defined what congruent means, we're using this word that we just defined in a definition of midpoint. Okay, so midpoint of a segment is a point that divides the segment into two congruent pieces. Basically, it's the point in the middle of the segment, right? Okay, so that's what you're. So, there you go. If I have segment AB, and there's a point P between AB, and the distance between AP is 2, the distance between PB is 2. Is P my midpoint, guys? Yeah, P is my midpoint. Okay. So there you go. P is the midpoint of AB. Obvious. Okay. So I could also say then AP is equal to PB. Remember when I say AP, this means distance of AP, right? Distance of AP is equal to PB. Oh, I could write the segment AP is congruent to segment PB. Okay, they all mean the same thing. If P is the midpoint of AB. Okay. Now, a bisector of a segment is something, therefore, thing that intersects the segment at its midpoint. So does anybody know? So now that we talk about midpoint, what do you think? What does bisector do? Anybody? Like you're bisecting something. What does that mean? Anybody? How about Alvin? I don't think I've called you. Alvin, what do you think? Any idea? If I'm bisecting something? Yeah, so I'm going to bisect a segment, right? What do you think I'm doing then? I am making the segment into two equal pieces, right? So, can a bisector be a point? No, because if it's a point, it's a midpoint. Okay, so there's a special name for that one. So then what can go through the midpoint to become a bisector? So how about Joseph, give me one. What do you think? Yeah.
It can be a line.
Sure, it could be a line, sure.
Give me a line segment.
Huh? Oh, hold on. You gave me one. Okay, Jonathan, what do you think? He said a line could be a bisector of a segment. What else? Line segment could be a bisector. Sure. Can somebody think of another one? How about? Yeah, Killa. Angle? No. Ray. Yeah, ray could be a bisector. And there's the fourth one that people really don't think about. This one. Hold on. Okay. How about who haven't somebody? Raise your hand if you think you know. One person? Two? Oh, how about Jesse? Plane is correct. Plane. Yeah, because plane could go through a line segment, right? In the middle. And that plane is called a bisector. That's the one that's bisecting that segment. Guys, let me ask you this. Can you have a bisector of a line? Is it possible? No. You cannot have a bisector of a line because does line have a midpoint? No, line goes on forever, right? In the opposite direction. So does that make sense, guys? So there are four things that could be a bisector, meaning there are four things that could go to the midpoint of a segment. It could be a line, ray, segment, and don't forget the plane. Now, do they all have to go to the midpoint in a 90 degrees? No, that's what people always think in their head, right? When they're talking about it doesn't have to be 90. It could be in any angles you want, as long as these four things go through the midpoint as long as these four things go to the midpoint, right? They don't have to be 90. If it was 90, guess what it's called? Anybody? If these bisector goes to the midpoint and they make 90 degrees, what do you think? It's Ryan, what do you think? No, it's not Ryan. Eugene, what do you think? What do you think we call that? What do you think these things are called? Oh, okay, Lara. Perpendicular bisector. If they go through the midpoint in 90 degrees. So that's a special type, okay? But do not always picture perpendicular bisector in your head, okay? It could be in any English you want. As long as it goes through the midpoint of the segment. No, not line. You can't go. You don't have. Yes. Oh, line segment. You're right. Any question? Are we good? Yes? Good.